Hey everyone, and welcome. Ever wonder what makes your microwave beep just right, or how a traffic light knows when to change? Well, today we're going to pull back the curtain and reveal the secret brain that's hidden inside countless devices you use every day. It's a tiny, powerful chip that quietly runs our world. Let's dive in. Okay, so let's start with a little riddle. What could your TV remote, your washing machine, and your car's airbag system possibly have in common? I mean, once we're kicking back, one's a chore and one's a life-saving device. On the surface, they've got nothing to do with each other, right? But they all share the exact same hidden component.
And that secret isn't just in those three things, it's everywhere. Think about digital watches, traffic lights, even critical medical devices like pacemakers. Each one is a dedicated problem solver, designed to do one thing really well, yet they're all built around the exact same core technology.
And here it is. That secret is called a microcontroller. It's an entire computer, we're talking processor, memory, the whole shebang, shrunk down onto a single tiny chip. Its whole purpose in life is to do one specific job and do it perfectly. This is the hidden brain we're here to understand.
So, how do we even begin to wrap our heads around what a microcontroller actually is? Well, the absolute best way is with a simple analogy. One that perfectly explains the difference between a microcontroller and its more famous, more powerful cousin, the microprocessor.
This is the perfect way to think about it. A microcontroller is like a Swiss Army knife, a complete, self-contained system. It has its main tool, sure, the processor, but it also has all the other essentials like memory and ways to talk to the outside world built right in. Now, a microprocessor, the kind you've got in your laptop, that's more like a tool chest. You've got a super powerful central tool, the CPU, but it's useless on its own. You have to connect it to all these separate components, memory over here, peripherals over there, for it to actually do anything.
And that all-in-one design, man, it makes a huge difference. Because a microprocessor is just the CPU, it needs all these separate parts to function. But a microcontroller packs the CPU, the memory, and the input-output ports all onto one chip. This integration is the whole key. It's what makes them so much cheaper to produce, way more reliable, because there are fewer external connections to fail, and, of course, small enough to fit inside just about anything.
Okay, so if this thing is a Swiss Army knife, what are all the different tools packed inside? Let's pop the hood and take a quick tour of the main components you'll find on a typical microcontroller chip.
So, to put it all together in a more official way, a microcontroller is a single integrated circuit, or IC, that contains everything it needs to work. It's got a processor, memory, and ports to interact with the world. It's a completely self-sufficient system on a chip. That's the key takeaway.
The best way to remember these core parts is with a few quick analogies. The CPU? That's the brain, the part that does the thinking and executes commands. The ROM is like the permanent rulebook. It holds the unchangeable program or firmware. The RAM is its temporary scratch pad for doing calculations. And the I/O ports, those are its senses, letting it feel a button press or light up an LED. And just like a real Swiss Army knife has more than just the main blade, it's got the can opener, the little scissors, microcontrollers have specialized tools built right in too. Things like super precise timers, circuits designed specifically to control motors, or converters that let them understand real-world analog signals from sensors. They literally come equipped for the job.
Now, this incredible efficiency we keep talking about, it's not an accident. It's the result of some really, really clever engineering decisions made deep in the chip's architecture. Let's look at two of the biggest ones. The first big choice is all about memory. A standard computer uses what's called a von Neumann design, where the program and the data it's using have to share the same path to the processor. Think of it like a one-lane road. But most microcontrollers use a Harvard architecture. This design gives the program and the data their own separate superhighways to the CPU. The upshot? It can fetch the next instruction at the same time it's working on the current data. It's a huge boost for speed and efficiency.
The second choice is about the CPU's vocabulary, what kind of instructions it understands. CISC, which stands for Complex Instruction Set, is like giving the CPU a massive dictionary with a complex word for every single possible situation. But most microcontrollers use RISC, or Reduced Instruction Set. This is like giving it a small set of simple, powerful words that it can execute incredibly fast.
And just how reduced are we talking here? Get this. A super popular family of microcontrollers called PICs can run on as few as 33 basic instructions. That's it. 33 words is its entire language. And that radical simplicity is the whole point. It allows the chip to be smaller, faster, and use way, way less power. It's their secret sauce.
Okay, so let's bring this all home. We've looked at the design, we've seen the components, and we've uncovered the clever architecture. Now let's see how all of that translates into the massive impact these tiny chips have on our world.
It all boils down to that all-in-one advantage. Putting everything on a single chip makes them dirt cheap. It makes them incredibly reliable because there are no external wires or connections to fail. It lets them fit into the tiniest of spaces, and they sip so little power they can run on batteries for years. It's the perfect storm for embedding intelligence into anything and everything.
And that perfect combination has led to a scale that is just mind-boggling. We're not talking about millions of these devices, we're talking about billions being sold. These tiny, efficient brains are one of the most common electronic components on the entire planet. They are, quite literally, everywhere.
So, the next time you press a button on your microwave, use your car's key fob, or just see a traffic light change, I want you to remember the tiny, dedicated computer that's inside doing its one job perfectly. Now that you're in on the secret of the Swiss Army knife chip, the real question is, how many of these hidden brains can you spot in your own world?